Yes, fluorine has less electron affinity or electron gain enthalpy than chlorine. That is, fluorine has a higher tendency to pull electron towards itself. Means fluorine can become Cl minus. Fluorine can become, okay, I'll write down. That is, fluorine by accepting an electron can become faster chloride. What is its value? Value we found is minus 349 kilojoule. And fluorine, this process is not fast because of electron pair relation. Huh? Okay, now. Second, we have found that fluorine bonds break faster than that of the chlorine and bromine because of mutual repulsion. So now, see, when fluorine becomes fluoride, that this process is oxidation. This is also oxidation. So in that case, fluorine should be a better oxidizing than fluorine. But we have found practically fluorine is the strongest oxidizing agent. This question is very important. So today, before we go to the chemical properties, today we are going to discuss about this. And you can expect this one in any of the school exam or in the board exam. So that is the one which I did not discuss that day because I find that I'm going to take little more time and your time was almost over. So we'll write this question. This question will be a little long. The electron gain enthalpy of fluorine. I'm writing atom. No. Yes, fluorine is more negative than fluorine because molecule does not take electron, atom takes than fluorine. Yet, fluorine, is the strongest oxidizing agent. Explain why. Because see here, to take electron from others is called oxidation. So we find that fluorine is much better. Fluorine can take electron faster than that of fluorine. Then in that case, why fluorine should be the strongest oxidizing agent? Okay. See now. The question is, that when you take the electron within yourself, after taking electron, Cl becomes Cl minus, and fluorine becomes F minus. But whether the F minus will be more stable than Cl minus or Cl minus will be more stable than F minus. See, suppose you have gone to a market. Okay, I'm taking the boy. See, if you carry more than 10 kg of weight, then you feel you are not feeling easy. But you'll find of your same age that some people are there who is doing the work of a porter. He can easily take 30 kg bag and walk with you. But he is of your same age. Then why it is become difficult for you, and for him why it is easy? Because he knows the technique of sharing weight, but you do not know how to share the weight. If the weight is propagated throughout your body, then the weight per unit area is less. You carry in your right hand, the body balance get disbalanced. But he immediately takes on his back or head. In that case, weight is being propagated. So you do not know the technique, he knows it. So same thing is that once the chlorine becomes chloride and fluorine becomes fluoride, the size of the chloride is much bigger than that of the fluorine. And larger size ions are not stable in solutions. All right. So let me first write it. What are the advantage and disadvantage of fluorine? See here. After that, I'll write it. See, you can never get fluorine atom. You will always get fluorine molecule. So fluorine molecule will break down to give you two fluorine atoms. For that, what energy is required? The energy, we call it enthalpy, bond enthalpy, delta HA. Then after that, he is going to take 2 electron and it will become 2F minus. What is the energy? Energy is delta H electron. All right. After that, this fluoride must be stabilized. How it is being stabilized? Immediately is being surrounded by the water molecules. Suppose, say, you have scored a goal in a football game. Immediately you will find you will be covered by your other players to share the joy. Similarly, if you get wounded in the game, immediately you will be covered by your friends so that they want to share your pain or sadness. So in that case, this is done. Then what you do? We add here water. So you will find here immediately the water molecule is going to surround that. And by that way, it attains stability. Okay? We call the delta H HYD. We call it hydration enthalpy. Huge amount of energy is released. Same is the case of chlorine. If you understand the theory, no, you don't have to read so much, dear. See here, delta H, this is plus. You have to break it. So what you get now here? 2 chlorine. What you get here? You get now 2 chlorine. That is delta H. After that, you have added water. It is delta H, hydration enthalpy. You get here 2. Now see the interesting. You find that delta H Eg of F2 is less than delta H. This is in flow. This value is less negative means what? Is more. Less negative means more. Okay. So this value is less negative. This value is more negative. So that in that process, this process is faster. Now here, delta HF2, this value is much lower than delta HCl2 because we have found it is not only lower than chlorine, it is lower than that of bromine also. That is, you require very less amount of energy to break fluorine. Immediately the fluorine will be converted into fluorine. Fluorine molecule will be converted into fluorine atom. Okay. Second, what is this one? We find here delta H hydration of F minus is much greater than delta H hydration of Cl minus. So you have found 2 factors are in favor of fluorine. It requires less amount of energy to break fluorine molecule into chlorine, and after the formation of fluoride, it get extremely stabilized by water molecule. What is the disadvantage of fluorine? This value is more than that of chlorine. So two are in favor, one is in against. So ultimately, what will be the result? You will find fluorine will be more reactive than of chlorine. So let me wrap it. You don't have to write all this thing. We'll write down straight the answer. We'll write answer. Fluorine is stronger, is a stronger oxidizing agent than that of chlorine because of following two reasons. One, the bond dissociation enthalpy of fluorine molecule is much lesser than chlorine. What is the second one? The hydration enthalpy of fluorine of fluoride is more negative than that of chlorine. See, this is the oxidized product. After oxidation, it gets reduced. So we find the reduced product is more stable than the chloride. So because of that, if you see, we do everything in your life. If you find the future is more stable than the previous one. Because of that, you are taking tuition here. Why? Because you feel uncomfortable if you don't understand. See, if you think that if I go talk to sir and if he explains, then in that case, if you understand better, our result will be better. Otherwise, should you spend so much time and your father's money for coming to me? I'm not a god. So I'm also trying to help you. And you feel, see, suppose many of them you might have left, not because you have lot of reasons. You may have problem with the online teaching. You may have problem through your mobile, internet. Okay. But still you feel, I think we'll be able to gain something. So please remember, this is the product we get after oxidation. Fluorine is an oxidation. Any oxidizing agent help to oxidize others and itself get reduced. Oxidizing agent gain the electron. So it is the future of the product of fluorine. So it is more stable than this because of that. Okay, now we'll go for the chemical.
So done.
When 1 minute. Wait, let me get my copy. Ajay, by the by, all the physical chemistry, all chapters, so many numerical I have done. Did you go through it? Those numericals? Hello? Or no time? Hmm? Hello? Whenever I ask you something, why you don't reply? Did you see those numericals? Huh? Then what for I have taken so much of problem or doing all this problem? Doing all this thing? I'm not supposed to appear in exam. Then I did not do. Okay? So now, chemical. First you will do oxidation. So first we will try to understand. Then we'll write. This is NS, NP, you know, P has three orbitals and D has 5. And here I'm going to write oxidation. So what is the electronic configuration of halogen? NS2NP5. So I'll put here 2. 5 means there are 5 electrons are there in p orbitals. You know, whenever you fill up the electron, you have to fill it up first 1, 1, 1. According to Hund's rule of maximum multiplicity. After that, they will go for pairing. So it will be, it has only one unpaired. So here it can be either -1 or +1. If this one breaks, see what will happen? It will go here. So this will be +3. If this breaks, it will go here. +5. If this also breaks, okay, it will be this. So this is +7. Please draw. Let me have a glass of water. So finished?
Yes, sir.
Okay. So what are the things first we are going to write? We'll write this is one. I'll write that A. Halogen show oxidation state from -1 to +7. All right. See, it is given here. B. Fluorine shows oxidation state of only -1. So question will be there. Why? See, fluorine does not have d orbital. To show +3, this is required. So this is abolished. No. See, it can be +1, -1, or +1. Why it shows the +1? Why it does not show +1? Because fluorine is the strongest electronegative element. Nobody can take electron from fluorine. Fluorine only can take electron. All right. So we'll write here fluorine shows oxidation state of only -1 because it is the strongest electronegative element and does not have d orbitals. Then C. Other than fluorine, the halogens, all halogens exhibit negative as well as positive oxidation states. Others will show. Why? Chlorine will show. Why? Because if chlorine combines with more electronegative element like chlorine and oxygen, it will show the positive oxidation state. Because next to fluorine is chlorine. But mind it, oxygen is more electronegative than that of chlorine. So when chlorine combines with oxygen and fluorine, it will show positive oxidation state. And same with the case of others. D. The stability of higher oxidation states decreases down the group. That we have found in each group, it is like this. So this much only I can tell you about the oxidation states of halogen. Okay.
Yes, sir.
So now we are going to discuss some of the compounds. just like you have done. Okay. So now I'll write reactivity with hydrogen. Is the same thing a repetition with hydrogen. All group 16 elements form hydrides of the type EX. Sorry, from wrong formula. It is HX. Now, why do you write HX? You know why? Because in this case, hydrogen is, in this case, it is a compound containing only two elements. Two elements only. Okay? Two atoms are there. Because of that, we write. Where X is equal to what? Fluorine, chlorine, bromine, and iron. We are not taking the astatine because astatine does not is a metal and does not behave like them, and these are not also called halogens. Okay, now you know what to do. We have to find out whether they're stable or not. So we write now here thermal stability. So that you know when you go down the group, bond length increases and thermal stability decreases. So you can write down thermal stability of HX molecules decreases down the group. Why? Due to increase in HX. No, I'll not write that. I'll write completely so that nobody can question. Due to decrease in the bond dissociation enthalpy of HX bond. But why? Due to because of the increase in the sizes of halogen because of the increase in HX bond length. So what you can write therefore? Thus, thermal stability HF is greater than HCl, greater than HBr, and greater than
Done, sir.
Okay, now see here. I want to break this bond. See here. When it is in gaseous condition or in non-polar, in gaseous condition or in non-polar solvent. If I heat here, HX, it will give you hydrogen atom and halogen. This hydrogen atom is what we call it nascent hydrogen, no? So I can use it for reduction. And if I put it in water, if I write here aqueous, this bond is highly polar here. You don't have to heat it. It will immediately dissociate to give you this. So any solution where you have H plus ion, then it is called acidic solution. So this is the application. This is a theory, and this is the application. Why should you break a molecule? We break a molecule to get something. See, you buy nuts from the market. Why do you break the shell? Just to see the seed is there. You know it very well, its seed is there. You break it to eat. So, good next one will be reducing capacity. What we write now here? Reducing capacity of HX molecules. See, this breaks immediately. So this is the strongest reducing agent. This hardly breaks, so it is not a reducing. So reducing capacity of HX molecules increases down the group due to decrease in their thermal stability or decrease in their bond dissociation enthalpy. So what should I write now here? Thus, reducing capacity, it will be HF, HCl, HBr, HI.
Done, sir.
Okay. So now we'll go for next one, acidity. Huh? So acidity, I'm not going to write this one. I'll simply change it. Answer is same, word by word same. So we'll write now here acid, and this is the statement. Write down. See, my purpose is to make a little thing simple for you. It's not that I'm a great knowledge of human, because I was also student like you. So I always remember those days. Many things were not discussed to us to a great length. So if moment you don't understand, you have to buy heart. Science is not a subject to buy heart. Science is reasoning. See, we have a feeling that hydrofluoric acid is the strongest acid. No, hydroiodic acid is the strongest one. But hydrofluoric acid is extremely corrosive in nature. Because of that, we should never handle HF with bare hand. You have to wear gloves and you have to use it. Because if it falls on your skin, there will severe blister. Hydrofluoric acid is not even stored in glass bottles because they react with glass. Okay, now we'll go for its boiling point. Please remember, all the hydrides of halogen, HF, HCl, HBr, HI, except HF, all of them are gaseous. So if it is HCl, then it is called hydrogen chloride, hydrogen bromide, hydrogen iodide. When you dissolve it in acid, it undergoes, dissolve it in water, it undergoes dissociation. Then only it is known as hydrofluoric acid, hydrobromic acid, hydroiodic acid. So it is only the HF which is not gaseous, which exists in liquid state. That is for your entrance exam. All right, so I'll write down now boiling. And I told you what is the theory. Boiling point depends upon intermolecular forces of attraction. And intermolecular forces of attraction depends upon their sizes. So when you go down the group, sizes increases, intermolecular forces of attraction increases, boiling point increases. Okay? We'll write now. Yeah. The boiling point of AHX molecules increases down the group due to increase in their intermolecular forces of attraction, which in turn increases with increase in their sizes. So in that case, HF should have the least boiling point and HI should have the highest boiling. But however, HF has the highest boiling point due to the presence of very strong intermolecular hydrogen bond. Therefore, boiling point HCl is lesser than HBr is lesser than HI, but HF has the highest. Note, all these hydrogen halides means what? HCl, HBr and HI are gaseous, while HF is liquid.
Done, sir.
Wait, sir, don't rub it, please.
Oh, sure. Now see, immediately response. Now reactivity with oxygen. All these elements react with oxygen to form varieties of oxides. Fluorine forms two oxides, but these are not that stable. These are not that stable. Okay. OF2 and O2F2 are formed where oxygen has positive oxidation potential, others are all negative. Oxygen is found to be positive. Why? Because fluorine is more negative. Where oxygen has positive oxidation states of +2 and +1. Respectively. This is called oxygen difluoride and this is called oxygen monofluoride. So whenever we write a compound, first we write positive, then we write negative. Chlorine is more electronegative than oxygen. Because of that, we write oxygen on the left and chlorine on the right. So because of that, OF2 is called oxygen difluoride and O2F2 is called oxygen fluoride. So this is important. B. The other halogens form oxides with different oxidation states. Their stability is iodine is more stable than chlorine and chlorine is more stable than bromine. Bromine is less stable. Oxides of bromine is less stable. The oxides of halogens are not stable and some of them are explosive in nature. Then D. Cl2O and ClO2 are used for sterilization of water. Sterilization of water. Okay. Suppose you want to kill all the germs in water. This is supposed to be done in municipality. Forget about Shillong, they do not do it. Okay. Sterilization of water for drinking purpose. For drinking purpose and for bleaching.
Done, sir.
Now we'll draw some structures which is there given in your book. Okay. This is Cl2O. So this is the structure of ClO2. This is ClO2. Then Cl2O6. I'll write down the oxidation states. See here, it is chlorine is more electronegative than chlorine. Oxygen is more electronegative than chlorine. So this is +1, this is +1, this is -2. See here, -2, -2, +2. This is +7. And Cl2O7. This is most important for your exam. This one. Okay. So this is this.
Yes, sir.
So now we will go for individual number. Chlorine. Okay, chlorine will never get in free state. So now we'll go for preparation. Okay, first one we'll do laboratory. So how do you prepare it? In laboratory, chlorine can be prepared by the oxidation of HCl. Oxidation of HCl by manganese dioxide, KMnO4, etc. Okay, okay, I'll write one more. Lead dioxide, KMnO4. My handwriting is very bad. Okay. By heating a mixture of manganese dioxide and HCl, chlorine can be obtained. In your book, the equation is given like this, so I shall also write like book. After that, I'll explain. 4 HCl, manganese dioxide will give you MnCl2, 2H2O, and Cl. Write it, then I'll explain. Finished? Now, how to remember? I told you, no, Dawn principle, Dawn. See here. First, manganese dioxide is having more oxygen. If you heat it, it gives you MnO plus O. So this is what? Decomposition. Then come oxidation, because we know atomic oxygen is very strong in oxidation. So right now here, 2HCl plus O. See, H2O and Cl2. So out for Dawn, we have done D, we have done O. Now the next is what? N is neutralization. See, metal oxides are basic and this is an acid. What will happen now here? MnO plus 2HCl it gives you MnCl2 and H2O. This. So see here. MnO2, 2 plus 2, 4. 4 HCl, it will give you what? MnCl2, 2 plus 1 plus 1, 2, 2H2O plus. Please remember, this is not my theory. this actually happens inside your flask. So BO.
Done, sir.
Okay. Now in laboratory, HCl is chlorine is prepared by heating a mixture of sodium chloride, manganese dioxide, and concentrated H2O. Why? We don't take HCl because HCl contains a lot of water. So what we are going to do? We'll write now here NaCl plus H2SO4 that you have already learned that it produces volatile acid because it is non-volatile. So what it will give, you have already learned it. NaHSO4 plus what? HCl. Temperature should be less than 420 Kelvin. So let me write it here. Now see, HCl is produced, manganese dioxide is already there. So you know the equation now. 4HCl plus MnO2, it will give you now wait. Now 4HCl will react with manganese dioxide. I have done some mistake or what? No, I have not done mistake. 2HCl plus, because here sulfuric acid is liquid, this is gaseous. So this is the one which is going to react. So you will get now here manganese sulfate. Okay, 2 hydrogen and 2 hydrogen 4, 2H2O plus Cl2. All right, how many HCl are required? 2. So I shall multiply it by 2. So I'll add it. This and this bond. So 2 NaCl plus 1 plus 1, 2. No, it will be 3. 2 plus 1, 3 H2SO4. Okay. And MnO2 will give you 2 NaHSO4 plus MnSO4 plus 2H2O plus Cl. This is for laboratory. But if it is asked, you can do from manganese dioxide HCl also, no problem. In exam, if you find this equation is difficult, you write the first one. See, in both the cases, we have to heat it. You can create chlorine also, but without heating. Okay, finish it, then I'll do without heating.
Done, sir.
Okay. Now, KMnO4 produces chlorine from HCl at room temperature. That is, you don't have to heat it. Suppose you do not have gas, what will do? So we will not go for manganese dioxide. We will go for carbon. We will write now here 2 KMnO4 plus 16 HCl. It will give you 2 KCl, 2 MnCl2 plus 8 molecules of water plus 5 chlorine. Okay. Now, 4. Chlorine can be instantly generated from bleaching powder that all of you have seen it at your home. Bleaching powder on reaction with water or HCl. See, moment you open packet of bleaching powder, strong smell comes down. There is nothing but chlorine. Why? Bleaching powder reacts with the moisture of the atmosphere, and the chlorine gas comes out. So the formula of bleaching powder is CaCl, OCl. In some book they write COCl2. This is wrong. So how to remember? How to remember? Suppose, say, I want to call someone from you. Decide whom should I call. Don't tell me a difficult name. Anyone, tell me your name. Say I want to call the lady Grace, and she is little far. When I call Grace, she does not hear. Then next time, how should I call? In that case, I'll put some more power into the word. I'll say Grace, oh Grace, like that. See here, CaCl, OCl. Remember this one. So to that I add water. It will give you calcium hydroxide. See, after putting bleaching powder, you get a white powder. Now this is number calcium hydroxide, and the gas which comes out, which is you feel very difficult to breathe. This chlorine. Chlorine gas is extremely harmful for us. It affects our mucous membrane. Immediately, you'll find you have developed running nose. Okay, so one has to be careful in handling bleaching powder. Then, if you react with HCl, okay, so if you write here 2HCl, it will give you calcium chloride, then H2O and Cl. So this you can immediately prepare at room temperature, or not only any temperature, even below 0 degree also you can generate. Now,
Done, sir.
okay. So wait. Now we'll go for commercial preparation. we require huge amount of chlorine for making bleaching powder. So chlorine can be used for making bleaching powder, or chlorine can be directly used for bleaching. And it is also required to make different types of organic pesticides. So now we'll go for industrial preparation. Okay, so one will write here. One is called Bacon's process. In this process also we oxidize chlorine, but we do not use any oxidizing agent. We simply use air. And by that way, our cost is reduced in presence of a catalyst, copper chloride. Okay. HCl is oxidized by air in presence of copper chloride as catalyst at 723 Kelvin. So I'll write now here HCl plus O2. So I have to write here 4 HCl CuCl2 723 Kelvin. It will give you water and chlorine. Second one is by electrolytic method. In this process, a dilute solution of sodium chloride. Dilute solution of sodium chloride is called brine solution. Dilute solution of sodium chloride is electrolyte to obtain chlorine. See here, I'll write NaCl aqueous, Na plus and Cl minus. Okay, so you have done electrolysis. You can write here electrolysis. So here will be cathode and here will be anode. So anode is what? Well, right now we have 2Cl minus gives you Cl2 gas plus 2 electron. But in this process, what happens is water also undergoes dissociation because the dilute solution. So you will get now here H plus and OH minus. So here the electron will not go to sodium, electron will go to hydrogen. So you will get now here 2 plus equals 2 electron. So you will get now here hydrogen gas. So hydrogen gas you get as a byproduct. Okay, enough for today. Oh, Riddhiর বইও তো বাই হচ্ছে না আমি ক্লাস 11 এর বই রাখছি তাও জানি
Thank you, sir.
বাই বাই
My sir.